In 2026, a question started getting harder to ignore. What if ADHD isn't one condition, but several different paths that end at the same label? Because here's the twist nobody expects. When scientists combined genetic data from millions of people, they didn't just find more ADHD genes. They found deep genetic connections between disorders we usually treat as separate boxes. And buried in that map was an idea that could change how treatment evolves next. For a lot of people, focus might not improve by speeding the brain up, but by turning the background noise down. In this video, I'm going to walk you through what the genetics actually revealed, why it matters for real-world treatment, and why 2026 may be remembered as the beginning of a shift. No miracle promises, just surprisingly concrete clues. Quick note, this is science communication, not medical advice. If you think you have ADHD or you're adjusting treatment, talk to a qualified clinician. Now, let's build the puzzle from the ground up. For decades, the story of ADHD was often told in one simple line. Attention is low, so we increase attention. And yes, stimulant medications and other treatments help a lot of people. They can be life-changing. But there's always been a stubborn reality underneath the success stories. A large group doesn't tolerate side effects, doesn't respond well, or feels like the improvement is partial. And that raises a brutal question. What if we're aiming at the right symptom, with the wrong mechanism for a chunk of cases? This is where genetics becomes powerful, not because it gives easy answers, but because it doesn't have opinions. It shows patterns, and one pattern is crystal clear. ADHD is highly heritable, but not in a simple one gene causes it way. ADHD is polygenic. That means there isn't the ADHD gene. There are thousands of tiny genetic variations, each nudging risk a little. On top of that, sleep, stress, routines, school demands, work schedules, trauma, environment, support systems, everything layers in. So genetics is not destiny, genetics is probability. But when you add up probabilities across millions of people, something changes. The boundaries between diagnoses start to blur. A massive international project, using data on more than 6 million individuals, mapped the shared genetic architecture across a wide range of psychiatric conditions. And instead of seeing isolated islands, researchers saw clusters, families, overlapping highways of risk. ADHD showed up closely linked to other neurodevelopmental conditions, especially autism. That doesn't mean they're the same disorder. It means part of the biological risk seems to come from related developmental pathways, processes that shape how brain circuits form and stabilize early in life. And they didn't just find a few overlaps. They identified many genetic variants associated with more than one disorder, and regions of the genome that behave like hotspots, areas where shared risk concentrates. In plain language, for many people, symptom overlap isn't random. It can reflect shared wiring and shared developmental pressures, influenced by both biology and life context. Now here's why that matters for treatment. If the label ADHD can be reached by multiple internal routes, then the future probably isn't one pill for the label. It's the right intervention for the mechanism. Think about it like this. Two people can both meet the diagnostic criteria for ADHD, but their engines can be different. One might struggle most with motivation and reward, getting started, staying engaged unless something is urgent or interesting. Another might struggle with sensory overload, anxiety layered on top, or a brain that feels like it's constantly broadcasting 5 channels at once. The outward behavior can look similar, so the label is the same. But if the cause path is different, the best treatment path might be different too. That's the first big implication of the genetic map. It pushes us away from a one-size-fits-all story. Now the second piece, the one that feels almost cinematic, came from a more experimental direction. A study in Neuroscience pointed to a counterintuitive possibility. Attention might be improved not by adding more gas, but by strengthening the brain's brakes. In mouse models, researchers identified a gene called Homer as a key modifier of attention during a critical developmental window. When they reduced certain forms of this gene during that window, the mice became less distractible and performed better on tasks requiring sustained attention. The proposed mechanism is where the story gets interesting. The change appeared to increase inhibitory control in neurons of the prefrontal cortex, one of the brain regions heavily involved in planning, regulation, and focus. In other words, it may have improved the signal-to-noise ratio, less background activity competing for attention, less mental static. Let's be clear, that does not mean they found the ADHD gene. It does not mean there's a human treatment ready to prescribe, and mouse findings don't automatically translate to people. But it does mean something important. There are plausible biological targets for the idea that some attention problems are driven by too much noise, not too little power. And that changes how researchers think about future therapies. Instead of only asking, how do we boost attention? We can also ask, how do we reduce interference? That might sound like semantics, but it's a different philosophy of treatment. Now add a third layer that's been reshaping how we interpret existing meds. Large neuroimaging studies, including work using big data sets in children and adolescents, have suggested stimulant medications may not simply flip on the attention switch. Their effects appear to strongly involve systems tied to arousal, alertness, and reward, making the brain more awake and making effort feel more worth it. And a lot of people with ADHD recognize that from lived experience. It's not a lack of intelligence. It's not a lack of caring. It's that the brain's traction disappears, especially when sleep is bad, stress is high, the task is boring, or the day is overloaded. So now the pieces start to click. On one side, genetics and neurodevelopment. Multiple mechanisms can sit under the same label, and overlap across conditions is real. On the other side, experimental and imaging work. Focus can be improved through different routes, more arousal, better reward signaling, or potentially less neural noise. That combination is why people are even using the word revolution carefully in 2026. Not because we found a cure, but because we're getting a roadmap. So what could actually change in practical terms? First, how we classify and talk about ADHD. If ADHD shares genetic architecture with other neurodevelopmental conditions, it supports a shift toward dimensional thinking. Instead of treating diagnoses like hard boxes, we may focus more on core traits and systems. Inhibitory control, working memory, sensory processing, circadian rhythm and sleep, anxiety load, impulsivity, reward sensitivity, emotional regulation. That doesn't erase diagnoses. They still help access care, but it can make treatment more individualized. Second, how we discover new treatments. Genetic maps point to biological pathways. Pathways become targets. Targets open two doors: develop new drugs, or repurpose existing ones that already act on those pathways. Repurposing matters because it can be faster and safer than inventing everything from scratch. Third, how we design clinical trials. Right now, trials often lump ADHD into one broad group and look for an average effect. But if ADHD includes multiple subtypes with different mechanisms, averaging can hide real benefits. A drug might strongly help a particular subgroup and do nothing for another, and the average looks meh. Biology-informed subgroups could make trials sharper. People clustered by sleep circadian disruption, by anxiety comorbidity, by reward processing patterns, by biomarkers, by cognitive profiles. That doesn't mean everyone gets a genetic test tomorrow. It means the science is moving toward who benefits from what and why. Now, here's the part that has to land with the same force as the hype. Genetics is not a crystal ball. High genetic risk doesn't guarantee ADHD. Low genetic risk doesn't protect you. An environment isn't a footnote. It's a major player. Support systems, education style, job fit, structure, sleep, movement, therapy, coaching, community. These can shift outcomes dramatically. There's also a known limitation in many massive genetic data sets. They've historically overrepresented people of European ancestry. That can affect how well findings generalize to other populations. The future needs broader representation, not just for fairness, but for accuracy. And there's an ethical edge to all of this. If the future includes more biological profiling, who owns the data? How do we prevent misuse? Discrimination in school, work, insurance. How do we ensure risk doesn't become a life sentence or a new way to label people before they've even had a chance? So when you hear genetics will revolutionize ADHD treatment, the mature translation is, it can reduce guessing. It can replace blind trial and error with trial and direction. Now let me end with a picture you can keep. Imagine your brain as a room full of radios. Traditional approaches often try to increase the volume of the main station so you can hear it clearly. That works for many people, and it's real, but what the 2026 genetics wave put on the table is a second question. What if, for a significant group, the main station is fine, and the problem is that too many other radios are blasting at the same time? If future research confirms that in humans, it won't create a single magic fix, It will create options. And in mental health, options are everything, especially for the people who don't fit the standard story. So what did genetics reveal in 2026? Not the cure, the map. And a good map doesn't teleport you to the destination, but it stops you from wandering in circles. If you want me to track where this goes next, what becomes real clinical trials, what's just headlines, and which ideas are actually holding up, subscribe to the channel, because for the first time in a long time, the science is starting to explain ADHD from the inside, not just describe it from the outside.